Alright guys, so today we're going to talk about the vertex and the axis of symmetry of a quadratic function. Alright, so today's kind of day one of those shortcuts, and again, all we're going to focus on today are those two critical things, the vertex and the axis of symmetry. So how do I calculate those based off of a quadratic function? If I just give you that equation, how can I quickly figure those two things out? And so I want you to take a second and copy this down. So again, how do I calculate the vertex? And again, just like always, guys, make sure that we have it in that standard form that I told you guys. That's never going to go away. That's very, very important. After that, you have to identify your A, your B, and your C. Remember, that's that AX squared bx plus your c. Okay, once we have it in standard form, we've identified a, b, and c. What we're going to do is we're going to find the x value of the vertex. Remember, your vertex has to have x comma y, right? So we're going to start off with the x value. The way that we do that is by using the following little formula here. This is going to become very important. It's something that you're going to have to memorize. So x equals negative b over 2a. And if sort of looks familiar, that's because that's kind of from the quadratic formula. Remember, it's negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, guess what? If I get rid of all of this stuff over here, I'm left with negative b over 2a. So that's where this is coming from. So again, it's not something new that you have to remember. It's just make sure that you can separate those two things. All right, so we plug it in there, and we'll get an x value. Once we have our x value, all I have to do is plug that x value back in, and I'll get my y value. And again, I always want to write my vertex as an ordered pair as some x comma y value. Okay, so how do I calculate the axis of symmetry? And it's pretty easy. Once you've calculated the vertex, the axis of symmetry is simply going to be the x value. So again, once we have our vertex, our x comma y, our axis of symmetry is just going to be that x value. And again, we always like to write our axis of symmetry as x equals and then whatever value that may be. So we're going to start off with example number 1 here. So again, it says find the vertex and the axis of symmetry of the quadratics. And again, I keep repeating this because this is very important. How do I know it's a quadratic? Because it's x to the second power. And again, why are we doing this? Is to find the shortcuts eventually and how to graph a quadratic. Again, how to graph that parabola without going through all that crazy nonsense of the table of values, which takes forever. Okay. All right, I have the function here, f of x equals x squared plus 8 plus 6x. And again, if that f of x kind of freaks you out, don't worry. It's just, again, it's the same thing as saying y. And if you notice here, I have x squared plus 8 plus 6x. Now that looks strange because it's actually not in standard form. So I'm going to write this as, let's use y equals x squared, and it should be plus the 6x plus 8. All right, so let me erase this here, sorry. Okay, so what I want to do next is I want to identify my A, my B, and my C. And once it's in standard form, it's pretty easy. That A value is the one sitting right there. It's kind of hard to see, but we'll call that A. The 6 here is my B, and the positive 8 is my C. All right, and again, the way that we get the X value for the vertex is I have to do the following. So I have to use the beginning of that quadratic formula, the X equals negative B over. Okay, what I'm going to do here is I'm going to plug in my b value. I know my b value is 6, so this is going to become negative, put in parentheses 6 over 2 times, well, my a value is 1. So this is really going to be negative 6 up above and 2 down below my denominator. Well, what's negative 6 divided by 2? That is going to be negative 3. Okay, so what I've found so far, so here's my vertex. Let me write vertex. Write that. I've found my x value of my vertex, and that is negative 3. Well, how the heck do I get the y value? All I have to do is take this negative 3, plug it back into the original function, and that should give me my y value. Okay, so we're going to do that right below here. All right, so right below here I have y equals, and again, instead of that x, I'm going to plug in 60 squared plus, again, I'm going to use the second one just because it's in the form, 6 times negative 3 plus 8. And again, it doesn't matter if you put it the first or the second. It's just nice when it's in standard form. So I have negative 3 squared, positive 9, 6 times negative 3, which is negative 8, plus 8. Okay. Well, 9 minus 18 is negative 9. Negative 9 plus 8 is going to give me negative 1. So that's the y value. So my vertex is sitting at negative 3 comma negative 1. Okay, so all I've done so far is excuse me. All I've done so far is basically just provided the vertex. Again, how do I find that axis of symmetry? It's pretty easy. My axis of symmetry, and again, I always want to write it as x is equal to, and again, the x value is coming from the x value of my vertex, which is negative 3. So this is what I'm looking for. Now again, notice I'm not graphing anything today. All I'm really worried about is finding these two special parts of a parabola. So again, the vertex and the axis of symmetry. Eventually what we're going to do is we're going to piece all these important little pieces together to create my parabola. But right now all I have would be, let's say, the vertex and my axis of symmetry. But again, I have no way of knowing how wide or in what direction, whether this is going to point up or down. And again, that is where the y-intercept comes into play. That's where the x-intercepts come into play. So we can get a much better picture and I can understand where this parabola is going to go. So let's go to example number 2. Again, same deal. Find the vertex and the axis of symmetry of the quadratic. So again, we'll start off. I have g of x equals negative 3x squared plus 6x minus 2. And again, let's start off by finding that vertex. I'm going to use x equals negative b over 2a. Again, I'm going to plug in. Well, oops, I forgot to label this. My a, my b, and my c. So again, the nice thing was it was in standard form. So let's come back over here. I have negative, what's my b value? 6 over 2 times, again, be careful here, it's a negative 3. So now I have negative 3 up top in my numerator, and I have 2 times negative 3, which is negative 6 in my denominator. Well, what's negative 6 divided by negative 6? That's going to give me a positive 1. So my vertex, again, let's scoot over here and write it out. Whoa, what just happened here? Let me erase that. My vertex is sitting somewhere at 1 comma something. I need to figure out what that something is. So again, the way we do that is we have to plug it back into the original function. So again, I'm going to have negative 3 parentheses, that 1 squared plus 6 times 1 minus 2. So what's 1 to the second power? That's simply going to be 1. So I get negative 3 times 1 plus 6 times 1, which is 6, minus 2. All right, let me multiply here first before I add any of this stuff over here. Negative 3 times 1 is negative 3. I have negative 3 plus 6 minus 2. Well, negative 3 plus 6 is positive 3 minus 2. Positive 3 minus 2 is going to give me 1. This is kind of interesting. My vertex here is sitting at 1 comma 1. And again, how do we quickly find the axis of symmetry? So my AOS, again, we always want to write it as x equals, and again, this is coming from the x value, my vertex, not the y, but the x. So this is going to be x equals 1. All right, that's what you want to box in. So let's move on to example 2. Pretty easy, pretty piece of cake here. All right, so let's jump into the vertex. Same deal. So let's scoot over here. Again, oops, I always forget standard form, which is nice. Okay, my b here, you got to be careful, it's a negative 10. My c is negative 3. Notice we actually don't even use our c when we're trying to find the vertex or the axis of symmetry. All you're really worried about are the a and the b. Those are the ones that we really use. C, we use it at the very end, I mean, when we plug it back in. All right, x equals negative b. Again, I always want to write this just to be sure. Again, where do you think the biggest happen? Sitting right here at negative b. So x equals negative, and my b is negative 10. Oh, so you see what's going to happen there. That's again, that's the biggest part where people mess up. So 2 times a value, which is 2. So I'm left here with negative, and negative give me a positive 10 over 4. Whoa, this is weird. What is 10 divided by 4? That doesn't work out very nice. All right, so what I'm going to do is I'm going to give the decimal value. 10 divided by 4 is going to give me 2.5, and that's okay. I can get a decimal, right? So when you guys are working this out, don't panic. Get a decimal calculator if you like. My vertex is going to be sitting at 2.5 comma something. All right, and what I'm going to do right now is work it out. Plug in. Again, I used my calculator. I did 2.5 times 2.5 gave me 6.25, and then again 10 times 2.5 is minus 25 here. 2 times 6.25 gave me 12.5, and again, if you keep simplifying, you end up with negative 15.5, which is going to be the y value of my vertex. Negative 15.5. Right, and quickly kind of just finish off my axis of symmetry. Again, x equals, and again, this is coming from the x value of the vertex. It's going to be 2.5. So actually, when you're working these out, as soon as you find your x value right here, you can actually kill two birds with one stone. Write your vertex, well, half your vertex, in your complete axis of symmetry. All right, let's move on to the next example. Now, this one's special because if you can see, it's actually missing the b term. This is normally saying ax squared plus bx plus c, and I'm missing that b part. My a is -4, but my b, there's no b, so my b is actually going to be 0. C is -16. So let's find out the x value. Here, what's the funny x equals -b over 2. Well, I have negative, and then what the heck is my b? I don't have it, so it's going to be 0 over 2 times -4. Well, up top, negative and 0 is just going to be 0 divided by -8. Well, 0 divided by anything is just going to give me 0. My vertex is going to be sitting at 0 comma something. Right. And actually, let's cheat a little bit. Started it right. My axis of symmetry is x equals 0. All right, so I'll do the work real quick for the y value. Work, I put in 0, right? We see right here, 0 to the second power is just, well, 0. And 0 times -4 is just going to be 0. 0 minus 16 is -16, which is kind of cool. Whenever you have your b missing, it kind of makes your life a little bit easier because a lot of things will end up canceling out. So here's my y value. So my vertex is sitting at 0, -16. My axis of symmetry is x equals 0. All right, I guess that was it. So for examples, guys, all right, what I need you to do is pick any 7. Again, it's up to you, completely up to you. But again, I need 7, and I will collect this when I get back. Notice the instructions say calculate the vertex and the axis of symmetry. So again, in case you get one of those decimal questions, use your calculator. That's perfectly fine. They can't look at this one right here. What is it missing? This one's kind of cool if you want to try this one out. I would try this one out. This one's missing the last part right here. So again, you can pick any 7. I'll see you guys tomorrow.